Dr. Ramkumar sir, and good morning to all of you. A very warm welcome to respected Arunjit Chowdhury sir. We
Good
are
morning.
honored to have you in our AICT ATAL FDP on machine learning in medical image processing. Let me have a brief introduction about our honorary speaker. Mr. Arunjit Chowdhury is a CEO in IT company EBTS. He is working as a project director in a large IT company. He has a startup company to train students from industry standpoint. He has more than 25 years of experience in IT sector in the area of machine learning and SAP. He has executed project in above area as a program manager and delivery manager. He has been working in various technology like ANN, CNN and exploring various domain dataset like healthcare, finance and other. He is associated with more than 70 colleges till date. Sir, we are grateful to have you in our session. Thank you so much for sparing your precious and valuable time for us. Now over to you, sir. Requesting you to please start your session. Thank you, sir.
Okay, thank you very much and good morning to all. And I hope this is going to be a very interactive session. First of all, thank you very much to Ramkumar sir and the faculties and the college for giving me this opportunity. And obviously from a participant perspective, I'm very sure and I hope that you guys are all safe in this current pandemic situation. And while we are all at home and trying to trying to be safe and ensuring that we don't get into this problem, at the same time we also have to ensure that we have to keep on upskilling ourselves, right? We cannot stop at any point, and this is one area where we need to upskill all the time, whether it's IT or any area. You'll have to upskill on the latest trends. And today, essentially, I'm going to talk to you about the classification model, which is typically used in the healthcare data, whether it is normal healthcare data or even image processing, right? And obviously, yesterday you must have got some idea about what is machine learning and about regression and classifications and something about image processing. But my today's focus will be getting bit into a about what is machine learning, something which I feel is very important for you to understand, because I'm going to run some scripts, show you some scripts on Python, and I'll be showing it on two environments. One is on Python, that is Spider, and the second is Jupyter Notebook. Okay, so I will run through some scripts so that you can understand. Many of you may not be technical, does not matter, but understanding the flow and the sequence of executing any machine learning application or application script is very, very important. So even if you come from a non-IT background, please don't bother. I'm not going to get into the script and tell you what I'm doing, but understanding the essence and the flow is very important, right? Having said that, so let me start off with the agenda. So introduction is already done. Thank you, sir, for that nice introduction. I will get into machine learning. I will talk about some applications in machine learning, something on the machine learning types. This may be a revision for some of you, but I think it's worth going through it. Then we'll get into the classification type, and we'll have some hands-on where I will show you one healthcare sort of a data set, so you understand the flow and understand how you measure the efficiency of a classification model, which is typically used, which is very much used in the classification model. And then I will also talk to you about the healthcare data, where I'm going to use a support vector machine model, which is also part of classification. And I'll run through the script as to how we execute when we have so much of healthcare data, how do we measure the efficiency of the model, right? So that's going to be my focus for today's session. And if you guys have any questions, please don't wait till the end. You can always send a chat, and probably Ramkumar sir or anybody who's a co-host can stop me and tell me that there is a question which has been asked. So let's try to make it very interactive, because I feel that you coming from the faculty, there's a lot to learn from you as much as whatever little I can impart knowledge from my side, right? Okay. So I mean, we guys all know about AI. I mean, whatever definition you have learned about machine learning, can somebody tell me what is your definition of machine learning? Whatever you have learned yesterday, and what is your interpretation? How do you want? If you can put it in few lines, I would appreciate. I've kept my chatbot open here. So anybody wants to talk about what is a machine learning? What do you mean by machine learning? Ramkumar sir, how many participants are there? We have
18, sir, till now,
okay 18. So
but
this is
it
the
is
place.
200, sir, overall
Very good, very
participant.
very good. But I'm sure I'll be getting the message here, right? Whenever anybody chats here, it should come here, right?
Yes, sir.
Okay, okay. Anybody, please share your thoughts is very important because let's make it very interactive. I know many of you must be a bit early because generally the session starts at 10, but I requested Ramkumar sir because I'm a working professional. I need to wind up by 11. Sorry about that, but I thought let us get into an engaging mode. Anybody, please? Making machine to learn. That's from Kavita. Can you can you be a bit elaborate, Kavita? Study of computer algorithms that can improve automatic through experience by the use of data. Very good. That's a good definition. Implying artificial intelligence to machine through learning. Right, right. Okay. So machine learning is basically a subset of AI. Okay, so the way I'm going to say is going to define is like this. Okay. So first of all, you will have an input data, right? You will have an input data and you want to basically what you do is you want to simulate if typically if I had a data which I had to basically I'm trying to derive a pattern out of the data. If I have to do that visually, that would have been very difficult, right? So if I have a machine which is trained with that input data and the machine is basically trained, okay, and learns. Please forgive me for my spelling mistakes. Here is this is the way I teach, but just ignore my spellings. So the machine is trained and it learns through experience. And once it learns through experience, it derives a pattern out of the data. Very important. It derives a pattern out of the data. Once it derives a pattern out of the data, okay, then basically you can compare the predicted output which is coming out of the model, because once you have derived a pattern, the machine or the model can predict the output based on the input data. So predict the output based on input data. Okay. So the idea here is that when you do a prediction with the help of a machine, the machine should be able to predict in line or close to what is there in the input data. For example, if I have an image of an X-ray or whatever, I got various images, and there are algorithms which are used to train the machines through experience. As the machine learns through experience, the machine should be able to detect a particular image, detect whether there is a tumor in a particular message, in a particular image, and so on, right? So unless the machine is trained and trained and trained with multiple training samples, you need to know, very important, you should have a lot of training samples to train the machine so that machine will learn through experience and derive a pattern. And based on that, the machine should be able to predict what is going to be the output. And that output should be close to what is your input data. So instead of you as a human being, you can use that machine or the model to predict the output image or predict the output data. Okay. Does this make sense? Have you guys understood what I'm trying to say? So machine is trained and learns through experience. Through experience, it tries to derive a pattern. And based on the pattern, it will come with the predicted output, which you then compare with the actual output of the input data. This is how I'm going to define what is machine learning. Now, can somebody tell me there is something called training data and there's something called test data? Why do you need two sets of data, training and test? Can somebody tell me that? Why do you need a training data and why do you need a test data? Anybody? Kavita, Emerson, I see responses from you. Anybody else, or maybe any of you can respond on chat? Okay, so the training data is something, as I said, the training data is basically used to train the model, to train the machine so that machine learns through experience, right? Why do you need the test data? Once the machine is trained or the model is ready, you need to check the efficiency of the model, whether the model is giving you the output which is in line with what is the input data. So in order to do that, you need to have a separate set of data which has not gone through the training. This is a separate set of data which is not part of the training data. So once the machine is trained and the model is prediction is done, then you should be able to test the model with the help of the test data. And that's where you measure the efficiency of the model. So if your predicted output matches with the test data, that means your model is efficient. Okay, your machine learning model is efficient, which you can recommend to your customer. Okay, so today typically if I go to any medical practitioners, many of the doctors have got lot of tools available by which if they enter some symptoms into the system, it will tell you what is the predicted disease or what is the predicted prescription. It can tell you automatically because these are all machine learning tools which have gone through this learning based on lot of patient data, which has captured based on the various symptoms, the various diagnoses, the various prescriptions, and the various diseases that it has encountered. And accordingly, it has been able to predict. And that is the beauty part. Similarly, if when it comes to image processing, using a model, I should be able to predict, okay, if there's a particular input image, the machine learning model can be able to tell me whether there is a tumor or not. There's a cancerous tumor or there is not a tumor. Okay, so that is the good part, or that is the brilliance of machine learning. And as I said, as I tell a lot of people, no machine learning algorithm is 100% accurate. You will never get 100% accuracy. Even till date, there's a lot of research being going on, but you will not be having any situation where you get 100% accurate. It's not always easy, right? But the work is still going on. There are a lot of research organizations which are doing a lot of work on. Elon Musk has got an organization which has doing a lot of research on AI. Okay, so of course doing a lot of work on electrical vehicles also, but I'm just saying that there's a lot of work going on, but still we are not able to reach the 100% stage. But as a customer, if I were to implement a machine learning project, even if I get a 90 to 95% efficiency, that is good enough for me to predict to recommend to the client. Okay, great. Okay, so that is why you have got a training and test data. Any questions? I'll just pause for 10 seconds. Is there any question anybody has to any questions, or anybody wants to share something? Can I get a quick yes if you have understood? If you say no, then I'll understand. Yeah, papers show 100% accuracy, Kavita, but as far as my experience goes and whatever learning I have done in projects, we have never attained that. Okay, it has never come there. Otherwise, I would be very happy to recommend a 100% model to a client. But still, as you know, there are so many models. If I talk about classification model, there's so many algorithms which are being created, and the work is happening to such an extent that there'll be some algorithm, some sort of work which is being happening where you can probably reach that 100% accuracy. But as far as I know, and whatever projects that we have implemented, we have still not reached 100%. I mean, a lot of research papers may be saying that, claiming that, but when it comes to implementation in real life, in industry, I've never come to that. So, yeah. Anybody else? Can I get a quick yes from everybody? That's what I'll know that all of you are participating. Can I get a quick yes if you have understood till this point? Just type yes. It's just a three-letter word. Or even Y will fine. Okay, fine. So let me go ahead. So we talked about machine learning. So if you see the evolution of AI, right, how the AI has evolved, right? When AI has evolved, it initially started with expert systems. When I was in the early 90s, I was doing a diploma course in National Center of Software Technology, NCST, which is associated with Department of Atomic Energy. And there we used to write a lot of programs in C language, where we used to write an expert system program where, for example, as I talk to about medical example, that if I have a symptom where I go to a doctor, based on the symptom, doctor will ask me to do a diagnosis. Based on the diagnosis, it will tell you what is the disease or what is the issue I have. And then based on that, it will suggest any prescription. So these all data could have been captured using an if and else statement. Okay, where I write, say, if this is if this is the particular symptom, this is the particular disease I get based on the diagnosis. So I could write the various business rules. Okay, and then probably I could execute that, and then that expert system could tell me this is the probably sort of a disease that you will predict, or this is a sort of prescription that I would prescribe to the patient. But imagine that if my business rule changes, suppose there's a new symptom comes, or there's a new diagnosis which is coming based on the research done in the medical field, then you'll have to again change the business rules, right? You'll have to again rewrite the program, do a lot of rework, and this was a sort of a very, very tedious process, right? Once from the expert systems, then we came to machine learning, what I talked to, where there were machines where uh, basically were told to be were trained using some algorithms, so you didn't have to do any explicit programming. The machine was trained using some algorithms. Okay, and that machine was trained and it was asked to derive some patterns which I told you about. Then you have robotic process automation, RPAs. If you have heard of RPAs, there are a lot of business processes today. If you understand the concept of a business process from an industry standpoint, like for example, if I'm a customer and I place an order on a vendor, then the vendor, once I place a order on a vendor, the vendor will maybe manufacture that particular item. He will dispatch that item to me. He will raise an invoice to me on me, or a bill, and then I will make a payment to the vendor, right? So this process, if it is totally repetitive, I could automate it. I don't have to write a code, or I don't have to write any specific code for that. I can automate the complete process. So at any point of time, whenever this process happens, I can automate the complete process. So the once from the time of the purchase order till the time the customer makes the payment, the full process can be automated, right? That's called the RPA, robotic process automation. Then came the deep learning. And I think you guys have already heard about deep learning, where essentially we are talking of neural networks, you're talking of complex processing. So you started off with artificial neural networks, okay? Then you came to convolutional neural networks, which is specifically used for image processing, right? Which you want to identify a particular image. For example, the image, as I said, if you want to find out there is a particular tumor in a particular x-ray or an image, okay, or even for normal data, if I want to find out whether it's an image is particular animal or a particular letter, okay, I can use convolutional neural networks. Then came the recursive neural networks, which was used to basically capture sequence of a sentence. So if I know that this is a sentence, and then the machine learning algorithm being trained, it will able to tell me that what is the next sentence that will follow, or next word in a sentence that will come, right? So that's called the recursive neural networks. Okay, so there's a lot of analysis going on. There's a lot of work going amount in semantics. I mean, NLP is natural language processing. There's a lot of work going on in machine learning. Okay. So when I talked about the machine learning types, right? When I talk about the machine learning types, I'm sure you guys must be aware, but I just wanted to understand from you. Can somebody tell me what is regression versus what is classification? I think if you have already gone through the lecture yesterday, what is regression and why this is part of a supervised model? Anybody, please? So Sunil Kumar says supervised regression. First of all, what is a supervised model? Can somebody tell me what is a supervised model? Why it is called supervised? Correct. So classification. So when I talk, now first of all, okay, let's do. So regression is essentially where the output is a continuous variable. That means it is not a fixed, right? Okay. And suppose, for example, if I equal to y equal to mx plus c, a simple example, okay, where y, so what is y in machine learning terms? Supervisor is like it needs a teacher. It's not that, Kavita. Uh, uh, y is the output class. What is in machine learning terms it is called? Expert, what is in machine learning term it is called? Okay. So predicted output, that's right. What is the other way of calling it? So when you talk about supervised model, in supervised model, the pattern of the data is known in advance. You know the data pattern. Okay. For example, when I'm talking of a regression, and if I know y equal to mx plus c, so what is the pattern here? It's a straight line. It is a straight line, right? So as x increases, y increases. Okay, so if I talk what is x, so x is, what is x called? So x is called in machine learning terms, of course, x is called x coordinate when it comes to algebraic terms, but you want to machine learning terms, x is called an independent variable. X is called an independent variable. It is also called a feature in many of the books, or it is also called a predictor. Okay. What is y? Y is a output, or it is also called a dependent variable. So y is called an output, or it is called a dependent variable. Okay. And m, which is a slope from an algebraic standpoint, this is called referred to as a coefficient. So these are the very important terms you guys should know. So you have a dip, and this is only in a supervised model, because in a supervised model where the pattern of the data is known, you will have an output, you will have an input. So whenever you have an output, you will have a dependent variable, and there will always be one dependent variable. Please understand that. There will be always be one dependent variable. There could be multiple independent variables or multiple features. Okay. So this is an example of a regression. Okay. When you come to classification, as one of you have rightly said, it is a labeled, and it has got a discrete set of values. It has got a discrete set of values. So either it will say 0 or 1. That means a person is having cancer or not having cancer. That is an example. Or you could say that this could have a previous fixed set of images, like could be a dog, cat, horse, or a particular, from a medical standpoint, it could be a set of medical images, and each image could say whether there is a particular malignant or benign tumor. Okay. So where is a fixed set of values or discrete set of values, that's called classification. Now there also you will have one dependent variable, which is your output, and that output will be a fixed set of values, and against that you will have multiple input values. Okay. Can somebody give me an example of a regression, industry example of a regression where you have one independent variable, obviously, but you have multiple features. Can somebody give an example? Can somebody give an example? It could be medical example or non-medical. Don't I mean just give me any live example which you can think about where you have one one dependent variable and multiple features. Okay. So for example, let's say you have the price of a house, and the price of a house, very nice. I think Sneha was coming to that. So price of a house or a flat is dependent on how many. It depends on your square feet. It depends. It depends on the floor you're residing or floor you're going to reside. Then there are other parameters, could be your proximity to the mall, proximity to mall, or proximity to railway station. Okay, so you could have multiple such parameters which will determine the price of the house, right? So this is the example of a multivariate regression, that is multiple independent variables and regression. And the regression, why regression? Because your price of the house is going to vary, right? So this is an example of a multivariate regression. Can somebody give me an example of a multivariate classification? Can somebody give me an example of a multivariate classification? You'll not call it a multivariate classification, but give me an example of a classification with multiple features. Tumor types classification. Okay, very nice. So you could say tumor type classification. So you can say whether it is a particular category of tumor based on number of features, and that features could be various parameters in medical terms, which could various values, and those combination of values will decide whether the level of tumor, maybe it could be level 1, level 2, level 3, or whether it's benign, malignant, mild, or whatever. You could have different categories, right? So tumor types is one example. Then classification of animals. Yes, classification of animals. If you want to do an image processing of whether it's a horse or a cat or a dog, you can use, as I told you, you can use convolutional neural networks, which is part of deep learning, to do an image classification, right? Okay, so that's an example of a classification. So typically in supervised model, we have one is the regression and one is classification. Okay. The other important machine learning type is unsupervised model, though it is not relevant for today's discussion, but I just wanted you guys to understand. Anybody can tell me what is an unsupervised model? Knee osteoarthritis level classification, that's fine. Any classification where you have different sets of values is basically a classification data. Can somebody tell me what is an unsupervised model? Non-labeled data set. Non-labeled data set, okay. Give me an example of an unsupervised model. Can anybody can think about an example of a non-supervised model? Clustering. Okay, Emerson talks about clustering. Okay, so in unsupervised model, I mean, from the very definition, I will say that the pattern of the data is not known in advance. So you have algorithms which will go through these hidden patterns out of the data and try to come out with some patterns. And one of the ways of doing it is called the clustering. And how clustering is done, let me give you an example. Suppose I have got the age, salary of different persons who are coming to the mall. Okay, I'm in a mall and I'm capturing his age, I'm capturing his salary as part of a profile, and I also capturing his spending power. spending power means if I'm got 90% spending power means it's a very you know, he spends a lot, okay, and he's lavish sort of in terms in his spending behavior. If you have a lower, he's sort of a conservative or a thrifty person, right? And somewhere in medium is more of a conservative, right? So so once so I can do a clustering based on combination of age, based on a combination of salary and say sending power. So I say that there could be a category of people who have got high salary and high spending power. There could be some category of people which is low salary and high spending power. There could be category of high salary, low spending power, and high salary, high spending power. So I could have three or four types of categories. And then based on the category, I can classify, okay, as to what is, these are the four clusters I make. And then I find out as to what is the percentage of people in each of these categories. And depending on the population, I can, the mall can come out with a marketing strategy saying that, okay, if there are so many people who are basically they are spending more and also they are rich people, then I could come out with some more new products in the mall because they are more innovative. They like to discover new products and they want to buy products. Or if I have a person who's going to spend less in spite of him being salary is high, then I could come out with a strategy where I can come out with some promotional things. Okay, where you know, he could come out with some promotional offers. He'll be happy to buy that, right? So I can form a cluster or grouping people based on common behavior, and then I can come out with some strategy. Okay, so this is one of the examples. One of the examples of clustering. There's another very classic example of movie recommendations. When you go to Netflix site and the Netflix site gives you a movie recommendation, how does it give you that movie recommendation? That movie recommendation is based on an unsupervised machine learning model. Or when you go to Flipkart site and the Flipkart suggests to you some product, gives you some product recommendation, that product recommendation is again based on an unsupervised model. So this is actually, this is called, just as you have got clustering, this is called learning association in, sorry, this is called learning association as far as, sorry, I'll put it here, my mistake. When I have unsupervised, then one is I have a clustering and one is also called learning association. Okay. So this is how I have an unsupervised model. Okay. And the third type is called reinforcement learning. This is another very complex algorithm. And typically your normal robots or your self-driving cars, okay, or if you have the automated chess, there are a lot of machines which play chess, right? There are machines being trained on playing chess. Those are all based on supervised learning. Supervised learning essentially means that you learn and relearn based on the mistakes you make. And as you learn, as you do something right, you get a reward. And as if you do something wrong, you get a penalty. And the objective of reinforcement algorithm is how you can maximize your rewards. Okay. And self-driving cars is one of the very classic examples of where you use reinforcement learning, plus you also use convolutional neural networks to capture all the images of all the people or the traffic lights which it captures as it goes along the lane, right? It's very, very beautiful algorithm which have been written in the area of deep learning, right? So this is the third example of reinforcement. So you have a supervised learning where the pattern of the data is known. You have the unsupervised learning where the algorithms will dig out and come out with the patterns. So one is the clustering part and the other is basically the learning association, like the movie recommendation and the product recommendation. And the third is the reinforcement learning as you learn through basically as you make mistakes, you reinforcement, you learn every time until you get the maximum reward. So that is an example of reinforcement learning. So any questions on these machine learning types? Anybody has any thoughts, any questions? Okay. If you guys have understood machine learning type concepts, okay. Some of the examples of machine learning, as I said, medical diagnosis. As I told you an example of any doctors today, there are a lot of startup companies which are doing a lot of work on machine learning, and they are providing tools for the doctors to basically do an easy diagnosis, right? Cancer detection. Cancer detection is also, as I said, it's a very nice machine, very famous machine learning application where you can detect whether a particular image or a particular person has a cancerous tumor or there is not suffering from cancer based on various parameters, right? Another example of medical diagnosis which I would like to highlight, if you have guys heard of IBM, so IBM is has a tool called Watson, and that Watson is doing a lot of study on patient data, and it is coming out with some diagnosis tools by through machine learning algorithms by which it should be able to predict a particular disease or the prescriptions based on specific set of symptoms. Okay, so these are again the extent of research which is being done in the healthcare industry. Some of the non-medical is credit scorecard, fraud detection. For example, when I talk of a fraud detection, let me take an example. Typically, how do I identify a fraud transaction, right? So if I do if my daily, if I'm doing 10,000 rupees a month, I'm withdrawing in a month, and suddenly in a particular month, I'm withdrawing 1 lakh, 2 lakhs, 3 lakhs, for example. So there are ways by which through a machine learning algorithm can detect whether it's a normal transaction or it's a fraud transaction, right? So that's again example of machine learning. Credit scorecard. So using machine learning algorithms, you can generate a credit report for an individual, and that credit report will be used by a banker. When you go for a particular loan, it will tell you how much of loan you have to take, how much loan you are eligible for based on the credit report. Then your Google search is an example of machine learning. Then there are language translators. If you want to translate from one language to another, natural language processing. If you talk of various tools like the Google Echo, then you have the what is that called, Alexa. Okay, these are the various tools which are all running based on machine learning algorithms. The chatbot which you see on the website is also an example of a machine learning algorithm where based on different questions you ask, it will basically, the machine has been trained to give series of answers, right? Identifying a spam mail, and movie and product recommendation, as I said, already explained earlier about the unsupervised learning examples, okay, where movie and product recommendations, they are basically found out using unsupervised model, right? Now this is something I just want to explain you guys, this is very important for all of us to understand, because when I'm going to run some scripts for you, you should understand this flow, okay? And this is not difficult to understand, but you should, it's very important that you have it in your mind when you were, I mean, whoever is in the technical field or non-technical field, this is the sort of process you need to follow, okay? For example, you have a sort of a data, okay? You have sort of a data, and that data uh, is a classification data, right? And the classification data is identifying whether a person is having a benign tumor or is not having a tumor, right? And in that classification data, so when you have this data, actual data which is coming from from a medical institution or wherever, and that data is given to you as a data scientist, and you are supposed to predict or come out with a machine learning model, okay? So what I will typically do is, number one, I will, once I have this data, suppose I've got some 1,000 records of this data, right? So typically when I get a lot of data, right, many a times the data the data is to first undergo a data preparation phase. And when you talk about data preparation phase, essentially what happens is typical all the data which you get need not be the right data. There may be some data which is missing. There may be some data which is unrealistic. There is some data which has no, some null, or there is some garbage data is there, right? Because before you train the machine or the model with the data, you need to ensure the data is absolutely clean. And that's where the data preparation or the data cleaning happens. And typically in a data science project that I do in the industry, 60 to 65% of the time goes in data preparation. If my data is not correct, if my data is not proper, my model is going to give me wrong results. So it's very important that the data which I get from my customer, and obviously you are aware that who is the owner of the data? The owner of the data is the business or the customer. So if the customer does not give you the right data to feed into the model, you can always go back to the customer and say, hey, this is not the right data. Can you please give me the right set of data? Right? So once you have pre-processed your data, and you have ensured that your data is clean and correct, and okay, then you have to split the data into training set and test set. And why this is done, as I told you earlier, a training set is typically required because you need to train the model, okay, so that the model is coming out with some patterns. And typically the percentage is not less than, so at least 70% should be training data. At least 70% should be training data, and 30%, it could be 80% also, but the remaining could be test data. And as I said, test data is essentially used for predicting the output to test data is used to make sure that the model is efficient. Okay, now let's say that you have these 700 records, and you have got a y equal to m1 x1 plus m2 x2. These are the various parameters. X1 x2 are the various features, and y is an output which says whether a person is having tumor, or is having a tumor, or is not having a tumor. Or we can see 0 or 1. 0 means the tumor is benign, and 1 means the tumor is malignant. Okay, just two examples, 0 and 1 is the value of y. Now this data you have got from the client, you have split it into 700 records of test training data and 300 records of test data. Now what you do is you take these 700 records and you feed into the machine. The machine will go through some training and come out with a model. Will come out with a model. That model is based on the model. Meaning when you say model, it has come out with some prediction based on it has derived a pattern from the 700 records. Okay. Now what I will do, I will take the independent variables. I will take the independent variables of the test data, and I will enter this into the model. What I do, I take the 300 records of the test data, I take the independent variables or the features or the predictors of the 300 records, and I feed into the model. Once I feed into the model will come out with the predicted outcome. Predicted outcome means it will be either 0 or 1. It can be any values. So 0 means whether he's having a benign cancer, or 1 means a tumor, or 1 he's got a malignant tumor. Once I have this predicted, I compare the predicted output with the actual output of the test data. I compare the predicted output which is coming out of the model with the actual output of the 300 records of the test data. And then I will compare the predicted output and the actual output. And if I get an efficiency or an accuracy of close to 100%, that means this is the right model, or this is the right model which I can recommend to the customer for this specific set of data. This is typically how a workflow works. So you have a data pre-processing step where you clean your data, then you train the data, that is called model training. Then you do a model evaluation. In the model evaluation with the test data, you enter the independent variables of the test data into the model to come up with the predicted output or predicted dependent variable, and you compare the predicted output with the actual output. And if the outputs are close to each other, that means the model is efficient. These are the typical steps when you do any processing of any data using a machine learning models. Any questions at this point of time? Have you guys understood this concept? If you want me to repeat, I'll do that. Can I get a quick yes or no? I'll pause for 15 seconds at this point of time. Anybody has any questions? What about Sneha? I'm only seeing Sneha and Emerson as the most active participants. I would urge everybody to please participate, at least say yes or no. That is also good enough. Sure, Renuka, please go ahead. I think Renuka, if you can
Yeah,
unmute, it makes sense to ask your admin to unmute
yeah,
you.
sir. Hello, good morning, sir.
Yes, Renuka, go ahead.
Good morning. Sir, I have a doubt, sir. When we split data into training set and test set, if we use
Mhm.
randomize, then definitely it will
Yes.
affect.
So when you do the split, there is something called random state as one of the parameters.
Yes, sir.
And that random state will decide, it create an internal random number, and based on the random number, it does a split.
So
So
every time the
typically the random, yeah, sorry.
classification accuracy will keep on changing based on the data
No,
set
it
it is
does.
chosen.
It doesn't depend much on the whether you take this sort of data as a training and this other set. Now there is a different ways you could have multiple iterations of training and test set, but typically you do a random state of either 0 or you use a random state 42. There are few terms which are used, but it really doesn't make much of a difference. Okay, because
Okay,
what
sir.
happens is you have a set of data, you will make a split, and the split will maybe you can take first 5 records and then last 5 records as test set, or based on the random state variable, you can say I will take maybe this many records. So that's an internal algorithm which runs and which splits the data into training and test set, right? So that's a random state parameter. When I come to the machine learning algorithm, I'll show you
Yeah,
when
thank you.
I demonstrate you on this system.
I'll
Good
look
question.
forward to it, sir. Thank you, sir.
Sure, sure. Anybody else? I request all of you to speak because it is easier to speak than writing on the chat bot, right? Chat box. Okay, great. So now that you have understood this, now let us go to the. So as I said, a typical project life cycle starts from a business understanding. So very important is that in any project in data science, machine learning, you need to have a domain expert. So if I'm doing a healthcare project, if I want to if I want to come out with a model where I need to understand, medical image do process of various medical images, I need to have a healthcare domain guy who understand what his image is all about, right? And so domain expert is very, very important. Uh, as I said, the data, once you collect the data, the data generally will come from the customer, and then you do a data preparation phase. Data preparation phase, as I said, is very important, where you understand the data, prepare the right set of data to feed the model or to feed the training data into the model. Exploratory data analysis, because one of the things which is very important is that you have to, as you do find out the quality of the data, it is one of the ways to find out is using the EDA, exploratory data analysis. And one of the important things you should know is statistics. So because all these machine learning models they use statistical modeling, right? So you need to understand what is mean, median, standard deviation, what is coefficient of variation, okay? how do you find out the how do you find the correlation between a dependent or independent variable, or how do you find the correlation between multiple independent variables? Okay, so so it's very, very important you understand the statistic aspects, and that makes it easier to understand a machine learning algorithms. Okay, so once you have done the exploratory data analysis and all that, then you do the modeling. As I said, what is modeling? You basically, once you have split the training set and test set, the training set you basically feed into the model and basically try to train. Model evaluation is basically once a model is ready, your pattern is predicted, then you try to predict the output using model evaluation with your test data. And once your model is properly is efficient, then you basically deploy the model into your live system, or you also call the production system, so that you give it to the customer for starting using it, right? Okay. Okay, great. I think that's good thing we have unmuted. So people, please, it's better we all talk rather than chatting. Okay, because I mean, if you ask me to chat 20 words, I'll grow mad. Okay, I prefer talking and getting something clarified, right? Okay, now I'll just quickly touch upon some of the data pre-processing steps. Okay, these are very, very important before I get into a classification model. Uh, there are some few, I'm talking about Python here. There are various algorithms which are used. You have got Python, you have got R, there are various languages, there are various other tools which are available. There are various libraries which are used for machine learning from Google. Okay, these libraries are used for maybe image processing. There is something called TensorFlow, Keras. These are some of the libraries which are used very intensively in deep learning. Okay, so first of all, what libraries you're going to use is very, very important. Then when you're talking of a supervised model, as I said, once you have a data set, now that data set could be an image, a set of images, could be set of actual data. That images or the data need to be imported into my machine, into my through my scripts, through a library. I need to import it, and then I need to identify, okay, whether it's an independent variable or a dependent variable. So I need to know which is my dependent variable and which are going to be my independent variable or variables. Okay, as part of our data pre-processing, I also need to take care of missing data, and that missing data is essentially, as I said, if I have a missing data, I need to go back to the client, and the client has to tell me what needs to be done. Okay, then data categorization and splitting the data into training and test set. Okay, these are the important things we need to do. I will do one thing. I will just open one example. This is Python Spider, which I'll show you. If you see on the screen, let me take this out. If you see on the screen, this is the Spider interface. Okay, where you have the Python script which runs on the left hand side. You have the files which are going to execute on the right top. Variable Explorer is the basically whenever I'm executing a particular command and the output, if I want to see the output, I can see the output under Variable Explorer. And this is where my each script gets executed under, this is called the Python console. And once I execute the script, then it goes to the next line number. That means my script is executed. If there's an error, it gives you an error so that you can make corrections and re-execute that particular line, right? Okay. Now, for this particular set, I'm using a data called data missing.csv. Okay. And in this, I have got fields called a country, an age of a salary of a person, and a person who's going to buy a specific model of a car or is not going to buy a car. Okay. Now, having seen this example, can somebody tell me whether this is a regression data or a classification data or unsupervised data? Why, Sunil, why is it a classification data? Which is your dependent variable here? Why are we saying it's a classifier? Correct. Very nice. So this purchased, no or yes, okay, is a fixed set of values. That's a label data, and that's your dependent variable. Okay, and since it has got discrete set of values, it is a classification data. And then you have country, age, and salary. These are your independent variables. So your country, age, and salary becomes your independent variables. Okay, and so what happens when you get this as a set of data? Very simple example I'm giving you here. Now this could be, let's imagine this could be even multiple features for determining whether my, instead of purchased, whether my cancer is benign or malignant. Okay, just imagine that's a situation here. Now if this be the situation, okay, now the first important thing is I'll have to import my libraries, import my data set, and then I have to identify which is my independent and dependent variables, right? So if I want to show it in the script here, there are three important libraries which are there in Python. One is the NumPy, which is mainly used for numeric calculations. You have got matplotlib, which is typically used for graphicals. There is another important library called Seaborn, Seaborne. Seaborn is another. I will show you an example of Seaborn when I show you some cancer detection algorithm. But Seaborn is again another library which is used for doing a graphical representation. And then pandas is basically the library which is used for importing the data set. So if you see here, I will first import these libraries. Those who are technical, just don't bother about it. I'm just trying to do something which is required. This is the data set which I'm reading here. If I want to see my data set I can see here. Okay. Now, do you see there is something wrong with this data set? Is there anything problem with this data set? Yes, please unmute and talk, please. Yes, Sunil Kumar says missing value, right? So there are typically some missing values. As you see in the Germany, row number 4, there is a salary missing. And in row number 6, so age is missing, right? So this is an example, and that is generally represented by NaN, okay, in machine learning. So I will have to take care of this missing data. As I said, you should ensure their data is clean, and you should never, as far as possible, delete any data. If you delete data, that means you have less amount of training set to train the data. Okay, so as far as possible, unless it's really a need, you should avoid deleting any data, right? So what I'm going to do now is, typically I would have gone to the client and I would have told him, client key, I please provide me this missing data. Okay, so typically client will give you this data, or he may tell you, you make some assumptions and go ahead. So for this case, what I've assumed, that I will take average of the salary of all the current values and putting the missing values. I will take average of the age of the current values of the or existing values and put in the missing value. Okay, so what I'm going to do here, first of all, I will identify which is my dependent and independent variable. So my x means x is a independent variable and y is a dependent variable. So if you see, my x is my country, age, and salary, and my y is yes or no. Okay, now this is my function where I'm going to capture the mean of the this. So, and I will replace the missing values by the mean for the age and salary. Now if I see the value of x here, you will see that the missing values, you see 16,777 and some 38.7, something like that. So these are the average values which I have calculated using a function, and I have tried to take care of missing values. Okay, any questions still here? Anybody? Have you understood how you have taken care of missing data, how you have imported the libraries, how you have imported the data set, and how you have identified the dependent and the independent variable? Any questions till this point of time? Okay, wonderful. Now, there's another thing which I would like to show here. This is very important. Is what happens is that in machine learning algorithms, typically machine learning does not understand any text field. So if you see here a country has got different values like France, Spain, Germany, and so on, right? So what this actually does is, so what machine learning recommends that you need to convert this data. Nan is null value. Okay, it's a null representation that the value does not exist. Okay, so in this case, there there are different countries, but this needs to be converted into binary value for machine learning to understand. So for this to do that, so the machine learning algorithm, they use a process called data categorization. Okay, now what is data categorization? I will explain to you by this diagram. Sunil Kumar, I hope you have understood what is NN, right? So it's just a representation of a null data. Now see here, you have France, Spain, Germany, and so on, right? So what this does is that it converts it ultimately into an array. So if there are 3 countries, it creates an array of 3 variables. So you have, if there are 3, France, Spain, and Germany. So if it is France, it represents as 100. If it is Spain, it represents as 001, and if it is Germany, it is 010. Then again, if it is Spain, it is 001. So what it does is that it is replacing the country field by an array of variables, and the number of array depends on the number of country values. So in this case, you have 3 country values will be having an array of 3. Okay, and this process is called data categorization. Is my voice breaking, guys? Hello, is my voice breaking? I just got a message from somebody is basing. Okay, so whoever is getting this problem, can you please check your network? Okay, and at any instant, am I audible, right? Clear?
Yes, you are audible.
Okay. Okay, whoever has maybe please check your network if you're not able to hear me. Thank you. So this is the way I've done my data categorization. So what I've done is, depending on the number of countries, I split it up into number of array of number of variables depending on the number of unique country values. Okay, this example is called data categorization. Now if you see here, I'll show you how it looks here. Just ignore the script. I'm not here to explain you the script, but see the output here. Now that I've done this here, I go back to my script and I execute this. See what happens here. And there are 3 values here. Okay, now see what happens. If I go back to X here, do you see that my country value, which was 1 single value, now I have got 3 variables, 100, 001, 010, and then you have the age and salary. So the independent variable, which was initially comprising of 3 values, now it has got converted into 5, which is comprising of the age and salary, and the country field, which was having 3 unique values, has now been converted into an array of 3. And this is called dummy variables, dummy, dummy variables. Okay, this is what is called data categorizations. Have you understood this? Anybody has any questions on data categorization and why it is required? Because you need to convert any text field into binary format. Other machine learning algorithm doesn't understand text, it only understands numbers. Have you guys understood what I said? Why is it not showing? Sneha, you have not understood? Or Sridevi, you have not understood? Should I explain? Sneha, Sneha, I have understood. What about Sridevi? You did not understand? Sridevi, can you please unmute and talk? Why exactly you're not understanding? We have understood. Okay, fine. Please don't hesitate to ask. I mean, just shoot if you have any questions. Okay, fine. So once you have done this data categorization, this is where we are doing the split. And here, when you are doing the split, we are splitting it into 4 variables. You have got X train, X test, Y train, Y test. So you have got the X train, which is the training data independent variable, X test, independent variable, test data. Similarly, Y test and Y train is for the dependent variable. Okay. And here, if you see, my test size 0.2 means 20% will be test data and 80% is this data. And random state, this is where it decides how the data is going to be split. Okay. And typical random state 0 will be, it will take the maybe the first 7-8 values and the remaining values will be the test data. You could have different set of random state. And somebody had this question. So this is where you decide. So you can always do a study on this random state and decide how you want to split the data. Okay. So if I execute this, now if you see here, you will see here X train. This is the variable explorer. I see total X. There are 10 records and 5 variables. 1, 2, 3, 4, 5 or 5 columns. X test is 2 because 20%. X train is 8 because it's 80%. And Y is 10 and 2. Y test and Y train is 8. And obviously there is only one dependent variable. That's why they're not put anything here. It's default 1. Correct? So this is how you do a data pre-processing. So as I said, you do the input libraries, data sets, identifying the dependent variable, take care of any missing data, data categorization and splitting. Typically, everywhere you may not have to do everything because you may be having proper data. Of course, importing the data, importing the libraries, anyway, you have to do that. Import, identifying the dependent and independent variable. But if there is missing data, you don't have to do anything. If there's a data there is no text data for which you have to do some processing, you can ignore it. But splitting data is always needs to be done. So you need to always, of course, split the data into a training set and a test set. Okay. So this is an example of how do you do data pre-processing. Okay. Any questions on data pre-processing before I go to classification?
Sir, can I ask a question?
Please.
Sir, in the part of data categorization, where there was 3 district country was there, and
Yeah.
actually encoded with 3 base binary classification you have done, but that means 00001 and 01 command. Talk about if we have taken that Germany for 0 and England for 1 and France for 2.
You don't have to bother about that. Internally, it takes care.
Okay.
You don't have to say Germany is 1, Italy is 0, and Spain is 1. No.
No, I'm just asking why 3-bit? Only the decimal data would not work.
No. So this is what I'm doing. Data categorization I'm doing only for the text field.
Text field, but here country France was 000, Spain was 001, and Germany was 010.
No, you didn't get that. See, when I say 100, one means it is representing that the value exists for that particular that particular value. 0 means the value does not exist. So 100 internally the machine algorithm says that there is only one single value.
Okay, I got it, sir. Yes, I got it.
You got it, no? It is representing that one value means the value exists. 0 means the value does not exist.
Okay. Yes, I got it. Thank you, sir.
Got it?
Yeah.
Okay. Okay. Any other questions before I go to classification?
Morning, sir. It's
Good
me,
morning.
Sneha Kumari from Katihar Engineering College.
Yes.
Sir, I would like to ask what will be the impact if we divide our training and testing data set equally, like 50-50%, or almost equally, like 40-60%?
46. See, first of all, you should understand that more the training data, the more the data you're feeding into the machine, the more accurate, I mean, the prediction will be much better. Okay, because the model is going to come out with some pattern. So the more the data you provide as an input data, the prediction, or the more the data the more it learns through experience, and better it does sort of a pattern thing recognition. If you have less input data, then the machine learning algorithm will have less data to get itself trained and come out with a pattern. So always it should have maximum of training data and then minimum of test data. Have I answered your question, ma'am?
Yes, sir. Sir, next, I want to ask something else.
Sure. Please go ahead.
So, while doing pre-processing, when we are cleaning our data, like moving the redundant data and filling the null values, so once it happened to me, like I was working on a data set downloaded from Kaggle, and I have partitioned my data set 20% to testing and 80% to training data set.
Okay.
The thing, but the result what I was getting at accuracy, my accuracy was 1. Like it was showing 100%, no, sir. So is
And
this
what is the class? What is the data you had used? Was it a supervised data or it was unsupervised data? Of course, it has supervised data.
Supervised data, sir.
And was it classification or regression?
Classification, sir.
And which algorithm you used?
So linear regression.
Linear regression doesn't come under classification. Are you talking logistic regression?
Yes, sir. Logistic regression.
Logistic regression and logistic algorithm you use, and you got 100% what? You got confusion metrics at 100% accuracy?
Yes, sir. So, but I suppose maybe that data set was faulty because my
Yeah,
seniors told
possible.
me that it is not possible.
That's what I'm saying. You can never get an accuracy of 100%.
Right.
Either it must, I don't know. You can get close to 99%, but I don't know what is the data set all about. I mean, Haggle has got a lot of data sets. I mean, not necessarily all the data sets will be correct, but yes, it's a good example for you to understand. Okay,
Yes, sir.
just ignore the accuracy aspect, but the understanding the data, understanding the process, you have got various sets of data sets you can play around.
Yes, sir.
Okay, so
Yes.
that's what the idea of it. Okay, so just ignore the accuracy, understand the model, understand the algorithms, and then obviously accuracy, those algorithms are already available. So all that research work is all hard work has already been done. So you have to just see typically what happens now when I go to an industry, and if I have a data set, and this is a classification data set, and I have got multiple algorithms, there are various classification algorithms. I got logistic regression, I've got decision trees, I have random forest, I got naive Bayes theorem, I've got support vector machines. You can name it. There's okay. You also have KNN, right? Key nearest neighbor. Okay, so you have to try out different models with the same set of data and try out and see which is the one which will give the highest accuracy. And that's how it works. And all the models, all the algorithms do not give you the same accuracy.
Right, sir. Yes, sir. It deviates. Results deviates.
Correct. That's why you have different algorithms. And typically in industry, what I do in the industry today is I will try out a different algorithms with the same data set, and then try out and see the one which is giving the highest accuracy.
Yes.
Okay.
Thank you,
Does
sir.
it answer your question? Okay. Anybody else? Okay. So let's go ahead. Now we will now get into the classification model. Anyway, I'm going to give you this. I will sharing this with Ram sir after this session. Don't worry. At end of the day, we will all have this PPTs, so don't have to note down anything. Now, in this classification, I mean one of the very classic vertebrate data set if you have heard about. Okay, this is generally in most of the organization, most of the industries where they start some teaching or any of the you always start off with this vertebrate data set, right? Where typically you have these various features and then the label data which says whether it's a mammal or a reptile or a fish and so on. So these are the discrete set of values, or this is the dependent variables, right? And these are the set of independent features or the independent variables. Okay. Now in classification, these are the various models I told you that have a logistic regression, k nearest neighbors, decision trees, support vectors, naive Bayes theorem. Okay, there are various there's so many types of algorithm which are used for classification. Okay, and so what I will do first, I'm going to run one simple data set using logistic regression. Okay, and then I will explain to you what is how you measure the efficiency of a classification model, and then I will come to a specific healthcare data, and I will show you how using using the how in using that particular healthcare with that healthcare data, how do you execute and find out the accuracy. Okay, so now what I will do is I'm just going back to Python Spider. Let me close this. Let me minimize this. One minute, how do I? Let me close this. Let me minimize this. Okay, I'm going to change my folder to classification, logistic regression. Okay, and what I will do is that I'm going to open logistic regression.py. Now, before that, what I will do is just to clear all these variables and all that, I will just restart the kernel. Okay, just to so that it becomes a very fresh sort of a this. Let it restart. So I'll have a fresh set of everything will be starting from scratch. Command prompt. Okay. Now, so I'm going to open my data set. This is my data set. And in this data set, I've got a person who is logging into a portal. He enters his gender, age, salary, and whether he purchased a car or not. This is a similar thing which we did for the data pre-processing. Okay, absolutely same. Only thing I just added the user ID and age, gender. Okay, and this data is basically given to me as a data scientist. I need to come out with a model. And I know that this is a classification data because it's a purchase 0 and 1 is my classification data. Okay, now what client has told me that you don't bother about the gender, whether male or female. Don't bother about the gender, just focus on the age and salary and come out with a model which will predict the whether the person is going to buy a car or not going to buy the car. Okay, so what I do in this case, I first import my libraries. I'm anyway going to import my libraries. I am going to import my data set. I will identify my dependent variable and my independent variable. So if I see X is my age and salary, and Y is whether it's going to buy the car or not going to buy the car. Okay. Now in this case, if I do a data pre-processing, assuming there is no missing data, I don't have to bother about it. Do I have to do data categorization here? Do I have to do data categorization here as part of my data pre-processing? Anybody?
Male, female, that part need to be.
Very good. This should have been, you're absolutely right. This would have been the case, but in this case, since I'm ignoring the sex, right? So they say you don't care about the sex. So I will only agent salary. If they would have told to also do an analysis based on the gender, then you're right. I would have converted this into a binary. Absolutely. But in this case, it's not required because I'm ignoring that for my analysis as suggested by the client. Okay. But you're right. Otherwise, I would have done that. So that's why I have not done any data pre-processing step except for the last step, which is my training split and the test split. So if I go to xtrain, see here, if I go to variable explorer, I will see here X is 400 records, 2 variables. X test is 100 because 25% is test and 75% is training, and Y is again 400, Y test is 100 and Y training is 300. Okay. Now just ignore this for now. Just I'm just ignoring, just executing this, but you don't worry about it. I will, it will make things confusing for you. So I'm just ignore that for now. Now my model is ready. I'm going to now train my model. Okay. I have now what I've done is I have, why is there so much of echo coming? Am I audible?
Yes, sir, you're audible.
Okay, I don't know where some echo is coming. So what I did is that after doing my data processing, I fed those 300 records into the model with my dependent and independent variable. Okay, and got the model trained. Okay, and then what I did, I took the test data. I took the test data independent variable X test, and I came out with a predicted Y. Y predict is my predicted output coming out of the model. Okay, and then what I will do is I will compare Y pred versus Y test. Okay, I will compare Y test versus Y pred, and to do that comparison, obviously I would like to make sure that my Y test is close to Y pred. That means I have to, if that be the case, then my model is efficient. Now to find the model efficiency in classification model, I use what is called a confusion matrix. And what is a confusion matrix? I will explain you here. Very nicely, it's well explained. Okay, just imagine here, I've got a predicted value of Y and an actual value of Y. Sorry. And the predicted value here is 0 and 1. And my actual value is also 0 and 1, right? And assuming that I've got 100 samples, okay, and out of the 100 samples, it says there are 35 samples where my predicted value is 0. That means he's not going to buy the car. And the actual value is 0, where he's not going to buy the car. So there are 35. So this is giving a proper result. There are 50 cases where my predicted says that he's going to buy the car and actually also is going to buy the car. So that is 50. So this is also fine. So the model is behaving in line with the actual data. But look at this ones. Here you have a case where he has predicted that he's going to buy the car, but actually he has not bought the car. Okay. And this is where he is predicted that he does not, he has not bought the car, but actually he has bought the car. Now let us convert this into a healthcare situation. The healthcare situation says 0 means he has got benign cancer and 1 means he has got malignant cancer. 35 and 50 we are okay because my predicted and actual is merging. Let's take this 5. This says that I predicted that he has got cancer, but actually he does not have cancer. This is still okay. This is still okay. But if I look at this, where we have predicted that he does not have cancer, but actually he has got cancer, this is something very, very fatal. There's something very, this you cannot have. This is it's a model which will fail. If I have a situation where when he has a cancer and the model is predicted he doesn't have, it's a big problem, right? So these are examples of type 1 and type 2 error. So type 1 error is this one, which is also called false positive, and type 2 error is false negative. This is the most critical. That's why it is marked in red, exclamation. Okay. So you can never have a situation where you have this type 2 error. So if I want to measure the accuracy of this model, I will say the accuracy is 35 plus 50 divided by 100, which is 85%. And the accuracy or the error rate is 15 divided by 100, which is 15%. So my model will be most efficient when my accuracy is close to 100%. Any questions on this confusion matrix? Have you guys understood this? Any questions on this? Any doubts? Very, very important. Have you understood this model? How do you calculate the accuracy of a model? Okay. Can I get a quick yes or no?
Sir, I
If
have
you
a
have
doubt,
understood.
sir.
Yeah.
Sir, usually here we consider one positive class and one negative class.
Mm-hmm.
Yes, sir.
Correct. Yeah.
Sir, suppose if I consider being healthy as positive class and um, being diseased as a negative class,
Correct. Okay.
then my accuracy will be always with respect to positive class.
Correct. So you will have to see, you have to basically measure wherever it is giving you the right results. If
Okay.
wherever my model is giving you an accuracy, or giving a prediction which is matching with my actual data, that's where is accuracy, right?
Yes, sir.
Wherever it is different, it is basically error.
Okay.
Whether you measure in terms of either way, wherever you're measuring,
Okay.
what you want to measure is the efficiency of the model, where it is giving you the right results as per the actual input data. So if I see here, just the same example, this is the prediction and this is a true class and this is a predicted class. Okay.
Okay, sir.
Okay. I'm assuming here true positive means he's going to have the disease. False means he's not going to have the disease.
Okay.
Plus, okay. And here false is going to have the disease. Minus is not going to have a disease. So true positive means when it's predicting true, okay,
Yes,
and
sir.
correct values were true. So it is true means he's having the disease and prediction is all the same. Here is true negative means he does not have the disease and the patient also does not have the disease. Okay.
Okay.
This is the case of a type 1 error, which is called false positive, where predicted true but correct class was false. And the false negative is classified predicted false, patient does not have disease but actually do have the disease.
Yes, sir.
So this is
Either
how
way
you
we
do.
can, sir, either way we
Either,
can say no, sir.
correct,
Either
correct.
way we
See,
can consider.
it depends what is the problem statement.
Okay, sir. So whether I
Depending
am
on your
towards
problem state,
positive class or whether I am towards negative class, what I am going to
correct.
design the model, whether I am going to
Yes,
design the model for positive class or for negative class.
correct, correct. So what you finally want to achieve? That's what important.
Yes.
So if your achieving is that if I want to find a model to predict whether it is giving a right prediction of a malignant cancer or a benign cancer. So based on that, my accuracy, my model has to be, so model has to give me the right results based on the actual data. Simple as that.
So on which should we focus, sir? Like being healthy prediction should be the matter or predicting
So here,
disease?
if you see, here if you see the disease, this where the true positive, the true is basically having a disease,
Okay, sir. Huh.
and false is not having the disease. So you have to focus. Here I am focusing is basically I want to, the model should capture whether how many people are actually having cancer,
Okay, sir. Huh.
whether the model is giving a right prediction about the situation of the cancer patient.
Okay, so my positive class also always should be diseased one.
Yeah, typically that's what we do. Yes.
Yes. Okay, sir. Thank you, sir.
Okay. Now there are two more parameters to measure the confusion matrix. One is a classification I told you. One is a misclassification. There's something called precision. Precision is what? True positive divided by total true predictions. Total true predictions is TP plus FP. Okay, true predictions. Okay, and similarly recall is again TP divided by actual true. Actual true is what? TP plus FN. Okay, so in order for your model to be accurate, all these four should be close to 1. So if my Fn is close to, ultimately I have to take care of Fp and Fn, correct? If my Fp and Fn can be eliminated, then obviously this is close to 100%. So in most of the examples, even if you see in healthcare, there are 4 parameters which are used. One is the accuracy, one is the error or the misclassification, third is the precision, and 4 is the recall. And this is an example of how you calculate the classification accuracy, how do you calculate the precision, how do you calculate the recall. So if these 4 parameters, I mean classification is close to 100%, this obviously has to be close to 0, and my precision and recall is also close to 100%, that means my model is perfect. Okay. So if I go back to my formula here, now if I execute this, now what I'm doing in my confusion matrix, I'm taking 2 parameters, y test, which is my actual test data, and y pred, which is my predicted data. And now if I do CM, what is my accuracy? 65 plus 24 divided by total 100, that is 89%. Okay. So there is a way you can, a table you can get where you can measure. I'll show you the next example, where you can see the accuracy, you can see the recall, you can see the precision, and so on. Any questions on this? Have you understood what is confusion matrix? How do you measure? What are the KPIs which are used to measure the accuracy or the efficiency of a classification model? Is this clear to all of you? Okay, fine. Now what I will do is I will go to the other example, and here I'm using called what I'm using is a Jupyter notebook. This is another set of data. This is a very important data which I've used from cancer diagnosis. If I see what is the data is all about, now before I go to the data, I just want to touch upon in this presentation. This is the healthcare data. There are 2 graphs which I'm going to show you. One is called the scatter plot. Okay, what does a scatter plot do? A scatter plot tells you the correlation between a dependent and an independent variable. So if if these are dots are like this, that means this is whenever my independent variable increases, my dependent variable also increases. If I would have like this, whenever my independent variable increases, my dependent variable reduces. So I use a scatter plot typically to find out the correlation between multiple variables. So if I see in the scatter plot like this, when I say like this, means there are 2 variables, they are strong positively linear, means one increases, the other is also increasing, so they are quite dependent. This moderate negative linear, if one decreases, other increases. And third, if it is scattered like this, means both these variables have no relation to each other. So it's very important that when I have multiple features, I need to use a scatter map or a scatter plot to basically find out the correlation between my variables. There's another thing which we also use, which is called the heat map. What I've taken here, these are the multiple variables, independent features, and the independent variables. And this is again, the same features are in my x-axis, the same features are in y-axis. And when you say one here, one means I'm comparing mean radius with mean radius. I'm comparing mean texture with mean texture. I'm comparing with the same variable, hence the value is 1. That's very natural. But wherever I see values which are, say, more than close to 1, 0.85, 0.82, 0.92, that means that particular variable, that particular features are correlated to each other. That they are very close correlate to each other, positive correlation. If something is close to 0, like 0.21, 0.19, that means they are not correlated. That means those 2 variables does not have any correlation. Similarly, if I have minus somewhere, minus means that they are negatively correlated. Okay. So this is an example of a heat map which is typically used in the industry to compare the various features, okay, in the x-axis and the y-axis. So it can tell you which feature are strongly dependent on each other, which is impacting the output, which is whether the person has got a benign cancer or he's got a malignant cancer. Okay. Have you understood this point? I think can somebody go on mute if you're not speaking, please? I can hear a noise. Thank you. Have you understood the concept of the heat map and the scatter plot?
Yes, sir.
फर्स्ट ईयर का फॉर्म कब से भरने का ऑर्डर आया था सुजीत?
Co-host, can you please mute the particular person?
बैक वाला का?
Okay. So in this example, what I'm doing, I'm using various, these are the various, there are some 30 parameters, 30 input variables, mean radius, texture, perimeter, area, smoothness, compact. See, I'm not a medical practitioner, so please don't expect for me to explain all this. But I'm just telling you that these are the various features which are used to determine whether,
Hello, sir. Sorry, sir.
yes, yeah,
Sir, kindly, sir, make the full screen, sir.
sure, no worries.
Okay, sir.
So these are the various features, which are the input features, and then I will use a model to predict whether a person is having malignant cancer, which is yes, or less malignant or benign cancer, which is no, 0. That's my target variable is 0 and 1. Okay, this is going to be my this. Okay, now if I go to the data set, I'm going to go to this. Now this is my data set. I'm not going to execute this because already executed. There are 30 features here: radius, texture, perimeter, area. Okay, and there are some 569 records, out of which 212 is malignant and 357 is benign. Okay, and I have this input data and I need to feed this into a model and find out the accuracy. Okay, so what I first do is I import all my libraries. As I told you earlier, I import pandas, numpy, matplotlib. This is the Seaborn library which I use, which will be used for doing the scatter plot or doing the heat map. Very important library used in Python. Okay, then I import, this is my data set. There's a data set already in scikit-learn. Okay, load breast cancer. So this data set I load into my libraries. Okay, and this is my full data set, and this is the target values, which is 0 and 1. 0 means it is benign or less malignant, and 1 means is malignant cancer. Okay, these are the various data sets. Okay, this is the description. This is the description of the data set. Just ignore it for now. Then I print the target. This is my target, which is 0 and 1. What are the various feature names? So these are my mean radius, mean textures, mean perimeter. So these are my 30 dimensions or the 30 features, which is determining whether that particular person is having malignant cancer or not having malignant cancer. Okay. It says that I've got 569 records and 30 columns. Okay. This is Jupyter Notebook, by the way. I gave you two interfaces. The first interface was the spider. This is another interface which is used very extensively in the industry. Is called the Jupyter Notebook. Okay, also a very, very interactive environment. This shows me the top 5 records. This shows me the bottom 5 records out of the data set. This is the visualization of my data set. So what I'm doing, I'm visualizing my various parameters, and this shows whether it is blue or red. Green. Blue means either one is 0 and one is 1. 0 means it is blue. 1 means it is malignant. It is this. So this shows the distribution of the variables. Okay, is distribution of the my independent variable vis-a-vis my various variables that I'm comparing. So I'm comparing mean texture with here, for example, I'm comparing mean texture. I'm comparing for example, mean perimeter, I'm comparing with mean radius. Mean perimeter, I'm comparing with mean texture. Mean perimeter, I'm comparing with mean area, and so on. So I see the comparison with, and this is the example of a scatter plot. So this shows that this is positively related. This shows again this is positively related. This shows that this feature, perimeter and smoothness, has no relation with each other. That's why it is scattered like this, right? Okay, so this is the way I do a scatter plot. And another way what I do is the heat map. This is the heat map which I showed you. So here I see, if you see here, there's a strong correlation between mean radius and mean parameter. So if I take the mean radius and mean parameter, where is mean parameter? Mean parameter and mean radius, it is close to 1. Okay, mean parameter and mean radius is close to 1. Similarly, if I take mean area and mean parameter, mean area, mean parameter and mean area, again here is again close to 1. Okay, so wherever it is close to 1, that means, here if you see here it's 0.9, and mean area and mean radius, see it is close to 0.99. See here again in 0.99, which is what? Mean perimeter versus mean area. So wherever it is 0.99, that means they are closely correlated. This is basically how you measure the correlation of the various features. As it closes to 1, it is close to, they are dependent, they are correlated in a positive direction. As it is negative, it is correlated in the negative direction. And if it is close to 0, means they are independent of each other. Okay, this is how you use the correlation. Then I train the model. Okay, so what I've done, I've taken the X. X means I've taken all the variables other than my target. Okay, my 30 features. Then I took my Y, which is my target variable. So I have now I've split it into training set and test set. Here I'm doing this training test and select set. Okay, here they've used random state equal to 5, for example, right? And then I got the shape, how many rows and how many columns. Then I go to my evaluating the model. Evaluating the model, I used, okay, sorry, before evaluating, I basically run this particular model, support vector matrix. I did logistic regression there. I use support vector matrix model to train my data. Once I train my data, then I evaluate the model using the confusion matrix. So I do the confusion Y predict. I take X test and do a Y predict, and then I do a Y test, Y predict as input parameters for confusion matrix. And this tells me my efficiency, accuracy is around how much? 741, 66, 7. So 41 plus 66 divided by 41 plus 66 plus 7. That is my accuracy. If I want to print this, if I want to publish this, this is how it looks. My precision is 94%. My recall is 94%. F1 score is average of precision and recall, and accuracy is around 94%. So this is anything above 90, 95%. I say my model is perfect. Okay, so this is an example where I've used healthcare data to measure the accuracy or the recall, the various parameters which are used to measure the efficiency of a classification model. Okay, so this completes my session on classification. Is there any questions? Is there any, have you guys understood? Is there any questions you have?
Hello, sir.
Yes, sir.
Sir, any other parameter to classify the model, sorry, to evaluate the model related to classification metrics? Like here, one is confusion matrix. Similarly, suppose you are talking about ranking matrix, or suppose MAE, MAC, RMAC, this type of also parameter we can take for this scenario. So,
Yes, you can take multiple parameters, but generally we use, I've seen people using confusion metrics many a times
yes,
to
sir.
use the efficiency for the model, for the classification model.
Like suppose here, can we use kappa coefficient for this? Kappa coefficient is another also matrix like your confusion matrix. So this type of matrix can we use in this particular model? How to you verify that this particular matrix can be used in this model?
See, typically I in classification, generally, I've always heard of classification metrics and the recall and the precision, which is used pretty extensively. Okay, there may be some other models, but I've been mainly using this confusion metrics as far as
Okay, sir. Okay, sir. Thank you.
for classification. Yeah. Any other questions? Okay, Ram sir, I finished my session because I'll have to go to the other calls. Can we just wind up if you don't mind, sir?
Sure, sir.
बोलिए.
Any if there's no questions,
Dear participants, if you have any doubt, please ask.
hope you guys did you guys enjoy this session? Very important. Did you learn something from this?
Okay, no question. Thank you, sir, for sharing your immense knowledge to us. As you discussed, machine learning, robotic process automation, deep learning, supervised learning, unsupervised learning, reinforced learning. These topics will definitely going to be very fruitful for our future research purpose. Thank you, sir,
Sure.
for sparing your valuable time for us. Thanks, sir.
Thank you very much. Thank you for your time. Thank you very much. Bye-bye.
Thank you, sir. Dear participants, there is a slight change in our schedule. We are having a short break from 11:10 to 11:45, and next session will be start from 11:45. Requesting you to join the next session on time. Thank you.